Hello, we are Team 2 presenting our project for Engineering 202 Use-Inspired Design Project 2. The opportunity that we have decided to pursue is an improved foam dart launcher similar to existing Nerf blasters. Given the restrictions of the project, this will be done using the allotted project funds of $400, the time available to our group during this semester, and the fabrication tools available to us on the Polytechnic campus. Implemented improvements have been chosen pursuant to user wants and needs for the product, and continuous contact with users as a subset of stakeholders allows us to consider numerous areas of refinement.
Customer needs. This is done by interviewing users and compiling their feedback into this table. As you can see, the three most important items to stakeholders are the blaster has a long range, it's reasonably priced, and it's more powerful than current blasters. This next table is metrics of current Nerf products that can be compared to our prototype. Of all these blasters, the Apollo Rival has the greatest impact velocity at 14 meters per second. The Crossbolt blaster has the furthest range at 2377, that's in meters. And the Rhino Fire is the most expensive at $74.99, and the Strong Arm is the least expensive at $12.99. Now, taking all that into consideration, we were able to come up with our final requirements, and these were that the foam dart must have an impact velocity of less than 15 meters per second, so that could still be greater than any of the comparable products, but still safe to use. The dart has to reach 50 meters, far exceed any of the comparable products, and the prototype is going to be built for less than $200.
We created a prototype without an initial design using PVC piping. A bladder was created using 4-inch PVC pipe. A Schrader valve was connected to the end of the bladder to allow us to fill it with air. 1-inch PVC piping was used to create a pressure chamber twice the volume of the barrel, which was made from 1/2-inch PVC piping. Each chamber was connected using ball valves, PVC couplings, and PVC bushings. The first valve is used to release air pressure into the storage chamber, and the second valve is used to launch the darts. After initial testing, the launcher was painted in blue, purple, and orange. The prototype was tested by using a bike pump to fill the bladder with air. We used 60 psi as our standard testing pressure. The launcher was loaded by inserting a dart into the muzzle. The dart was fired by twisting the release bell valve. With the prototype, we achieved an average of 8 to 10 shots per bladder and an average distance of 55 meters. However, twisting the bell valves required too much strength to consider the prototype child-friendly.
We created a final product using the prototype as our reference and implemented electrical switches and buttons for easy firing. We used 4-inch, 1-inch, and 1/2-inch PVC piping to create the bladder, storage chamber, and barrel of the launcher. A heavy-duty anti-siphon valve was used to connect the bladder to the storage chamber. An irrigation control valve was used as the fire mechanism connecting the storage chamber to the barrel of the launcher. The PVC was connected using adapters, bushings, and of course PVC cement. The valves needed 24 volts to function, so we connected two 12-volt batteries in series, which then were connected to switches using alligator clips. Duct tape and electrical tape was used to secure the wires and batteries in place. In the last step of the fabrication process, the launcher was painted in blue, purple, and bright orange based on the stakeholders' likings. Using the same PSI as the prototype, we got an average distance of 50 meters with the first 3 shots fired. After 3 shots, we saw a significant performance loss.
Here is the table of specifications for our two prototypes, the first one being a manual launcher and the second one being our electric launcher. The barrel length and the PSI were both made the same for our two prototypes. The first prototype, the manual one, outperformed the second prototype in nearly every field. And this is reasonable because our second prototype is made to be best used by children.
Overall, we created 2 launchers that reach at least 50 meters. The users gave us positive feedback on the design and functionality of both products. Improvements could be made through custom-made valves and tubing if the launcher were to be produced commercially. The retail price would also be lower than the price of comparable Nerf blasters.